In this video, we're going to sketch the graph of a parabola by determining the vertex, the vertical intercept, and any horizontal intercepts. We're told that a toy rocket is shot into the air at a speed of 80 feet per second from the ninth floor of a building, which is at a height of 96 feet. Its height after t seconds is given by y equals negative 16t squared plus 80t plus 96. To start, let's identify that these coefficients, the coefficient on t squared, which we generally denote as a, is negative 16. Our value of b for quadratic equation, that coefficient on t, is 80. And our constant, which we denote as c, is 96. To determine this vertex, we're going to take t equal to the opposite of b over 2a. So t is then equal to negative 80 over 2 times negative 16. Putting this into a calculator, we can then see that t is equal to 2.5. To now find the y value, we'll replace t with 2.5 in that equation. So y will be equal to negative 16 times 2.5 squared plus 80 times 2.5 plus 96. And again, using a calculator, that will simplify to 196. So we know that the vertex is the point 2.5, 196. Now we'll determine the vertical intercept. This is going to occur when t equals 0. So when t equals 0, our value for y will be negative 16 times 0 squared plus 80 times 0 plus 96. And that simply equals 96. So the vertical intercept we can write as the point 0, 96. Next, we'll algebraically determine the horizontal intercepts and sketch a graph of this equation. So the horizontal intercepts are going to occur when y equals 0, and we need to find the value of t for which that's true. So we need to find t when y is set equal to 0. So setting up this equation, we'll then solve 0 equal to negative 16 t squared plus 80t plus 96. And using the quadratic formula to solve for t, we'll see that t is then equal to, and I'll draw this fraction, and in that numerator I'm going to have the opposite of b, which is negative 80, plus or minus the square root, and inside there I need b squared minus 4ac, so I'm going to take 80 squared minus 4 times negative 16 times 96. And that is all divided by 2a, which is 2 times negative 16. Simplifying this, I'm going to first simplify what's inside that square root. And so this will be t equal to negative 80 plus or minus the square root, and that entire expression inside that square root, that 80 squared minus 4 times negative 16 times 96, that all simplifies to 12,544. So I'm going to have negative 80 plus or minus the square root of 12,544, and that's all divided by 2 times negative 16, which is the number negative 32. Now, the square root of 12,544 happens to be 112 exactly, so I can simplify this further to be t equal to negative 80 plus or minus 112, all divided by negative 32. Now to finish calculating these, I'm going to break them down into two different numbers. The first will be t equal to negative 80 plus 112 all over negative 32, or t can be negative 80 minus 112, and that expression divided by negative 32. So for this first one, I'll have t equal to 32 over negative 32, which simplifies to t equals negative 1. For the second one, I'm going to have t equal to negative 192 over negative 32, and so that t is equal to 6. Now, t being equal to -1 would denote a negative time, which simply isn't relevant here. So the horizontal intercepts are -1, 0, and 6, 0, but only 6, 0 is relevant. So I'll write these down, that the horizontal intercepts are -1, 0, and 6, 0, but only 6, 0 is relevant. Now we're ready to sketch a graph. So I have an open grid here, and I'm going to make this lower left-hand corner 0, 0. I don't want a negative time, and I don't want a negative height here. So to start, I'm going to label this horizontal axis with t, which is time in seconds. And I'll scale it by starting at 0 on the left, and then I'll make every 2 tick marks worth 1 second. So 2 tick marks later, I'll write a 1, and then a 2, and then a 3, a 4, a 5, and a 6 on the end there. I'll label this vertical axis as y, which is the height in feet. When I scale this axis, I need to make sure that the vertex, which is going to be the highest point on this parabola, appears. And that occurs, that height value for that vertex is 196. So I need to make sure that that's on there. And I've got 12 tick marks here, so I'm going to make every tick mark worth 20, which means that the 5th tick mark I can label as a 100, and then the 10th I'll label as a 200, so representing 200 feet. Now I'm going to plot each of these key points. So the vertical intercept, when t was 0, y was 96. So I'm going to plot 0, 96, and I'll plot it as best I can. I can't get a whole lot of accuracy there based on the scale, so I'm going to write the actual point 0, 96 right next to it so it's clear. Similarly, I'll plot 2.5, 196, and I'll also label that. So I'll go halfway between 2 and 3 for 2.5, and then just under 200 for 196 on the y value. Then I'll go ahead and label that so that it's clear, 2.5, 196 as a point. The next thing that I can plot is that relevant horizontal intercept, which was 6, 0. So I'll plot that. And then I can use symmetry to get one additional point. My vertex is at 2.5, 196, and I have 0, 96. So I know that if I go an additional 2.5 units on the other side of that vertex, at 5, that output will again be 96, and I can label that as 5, 96. The last thing that I need to do here is to connect these with a smooth curve, making sure that it's rounded and pointing downward from that vertex. So I'll start at the vertex and make sure that it's opening downward. I'll go through those, and then I'll go to 0, 96. And I'm not going to put arrows because I'm not using negative time or height here.